Alright, now that the 53131A has been repaired and calibrated, what I wanted to do was I wanted to install the next two options. And these two things here are a high stability time base and a 3 GHz prescaler. And they're both clone components. But it'll be interesting for me to do this because my actual, the 53131A that I'm actually using is a proper official Hewlett-Packard set of both the prescaler and the oven. And so hopefully once we're all up and calibrated, we'll be able to compare the two and see if there's any real difference. Anyway, let's get started on this. And so the first thing we need to do is take the cover off our counter here. I like the way they made this unit because in this era that counter, you know, is easy to get into and out of, you know, for servicing purpose. Okay, so there we go. You'll notice that if we actually look down here in the power supply, there are a couple of the caps there. I'm not sure if you can quite see it at the angle, but a couple of those caps are bulging. So it certainly looks like that DEFPOM was right when he submitted that. So when he made a comment about it. So I will have to go order those caps or, you know, some replacements, and then just recap that power supply. Anyway, these are actually pretty easy to extend. To get the oven power supply, the oven time base in, we mount it over here on the side, and then this cable comes across and plugs into the unit here. Then this prescaler is going to mount here on the side, and this is going to connect into this connector here, and we'll bring that out through this little pigtail. So let's let me go get this guy on. So here we go. Now we can just push that out and bring that in. Okay. And now we need to do the same with this guy, but the first thing we need to do is to pop out that little plug there at the front, and you can see them, they're like the ones at the back there. So we're going to have, okay, there we go. It just took a little bit of squeezing, but we popped that out. And so in the actual proper HP one, there's actually another mounting bracket that goes in here, and then there is a bar that connects across the top of this unit and holds the front of the unit out as well. So you don't seem to get that on this one. Let's put this guy in, and then it doesn't really mount terribly flush there, but you know, the prescaler was inexpensive, and so hopefully it will actually end up. It's not a terribly, like in the great scheme of things, it's not a terribly complex piece of kit, the Prescaler. So hopefully it will work very well. Now it's supposed to actually be more sensitive than the original Hewlett-Packard one. So we'll have to give that a try when we get around to doing the updating. Okay, there we go. Let's grab the case again. Let me take a quick drink of water. Let's turn this over. Well, actually no, because we're going to want to get this in first. Okay, there we go. Come on, let's grab this guy. Put that on. Then we'll put this guy on. Then we'll flip this over and we'll see if it all pops up and starts working. Okay, so now how we're going to tell this. Firstly, what we're going to go do is, let me get that light out of the road here so you can see. So it's going to come back and say it's uncalibrated, but that is good. So turn it off. Let me turn this back on. Cal unsecure. Okay, so it remembered the calibration, so it's not an issue with it forgetting the cal. But what it is see, now we have this time base option, and so I can calibrate that time base against my GPSDO and get it to be very accurate. But we have to leave that running for 24 hours. So while we're waiting for that, let me grab another piece of kit and we'll try the 3 gigahertz Prescaler. Okay, so what I have here is I have an output from my 8672A, which I realized that I haven't done a video on the usage of it since I repaired it. Now I've got better counter and everything, so I wrote it up on my whiteboard. I'll do a video. So let's turn it back on again. And now previously you saw that when I used this I only had frequency 1 and frequency 2. Well, now I've got frequency 3, and so if I run that, you'll see I'm reading a 3 gigahertz signal. So I can step that down. Let me take that down to say 2900, 935, and you'll see that we're going to be a little bit out because remember we're not calibrated here, but we're working quite well. Let's turn down. We're at minus 20 dB there, and we're still getting signal. I don't know what the actual standard is for this, but that seems to be fairly sensitive. So, okay, I think it's actually all good. Now the I need to leave this running for another 24 hours before we can do the calibration on the back. So we'll come back in 24 hours and we'll do the calibration, and then we'll measure some other stuff and see how it goes. Well, it's been 24 hours since I added Jerry Sweeney's high stability time base to this guy here, and so now it should be fully warmed up. Now, I don't know if it's supposed to be 24 hours. The Hewlett-Packard one that I have, when you go look at its manual, it talks about the calibration of that. It says 24-hour warm-up minimum for the high stability time base. So that's what I have in this top unit. This is a proper HP option 10 time base. And this is connected to my GPS-DO. And so if we go and plug that in there, we can see that this was calibrated some time ago. And we're getting a signal here on this that is bouncing around on that last digit. Now, often that last digit will be because of the architecture of the counter. So let's go over here. Let's just jump to time, and then we'll take 1 second, and then run. And so now we should be gating every second. So you're seeing that we're bouncing around on that last digit, and when this was calibrated, it's lost 3 millihertz since then. So if we now take a look at the one from Jerry, and we put in gate, time, and we're going to want 1 second as well, and we run that. You see, out of the box, it's actually pretty damn close, but you don't really want to take these as they come out of the box. What you want to go do is go and calibrate them. Now, before we go do that, I thought it might be interesting just to take a look at them on my 54622 down here. And so let's go and drop this in now, and let's have a look. This is channel 1, is going to be the output from my HP, the proper HP unit, and output 2 is going to be the output from Jerry's unit. And now you can see that the waveforms are very, very similar. They're not a great perfect sine wave, and in fact, if we take a little look at, let me go and set up the trigger on, we'll set up the trigger on channel 2, because we'll swap channel 1 out here. And if we look at the output from the GPS-DO, it's a much nicer, much cleaner sine wave there. Now that could partially be because it's coming out of the GPS-DO, it's then going into a Symmetricom 6502 distribution amplifier, and it's getting cleaned up. But anyway, that's the signal that we're getting there out of it. So now, you can see that there is a little bit of movement coming on. You can watch the things roll in. So let's go in and actually calibrate the unit. Now, the way you calibrate these units is, and I showed this with the previous, we'll hold down the scale offset, we'll turn the cal button on, and then now we will have the capabilities select, crap, I keep jumping past it, correct, time base. And when we click on that and select enter, it asks me to supply an accurate time base to the channel 1. So now let's have a look and see what happens to the signal as we do the time base. So now it's ready, so I'm going to press enter, and it started calibrating. You can see the calibrating sign there. Now as it's calibrating, I would expect to see this to start moving back and forwards as it's looking to try and bring the signals into line. Now this won't be perfect because that's coming from the top unit, remember. You know, this is from the HP rather than the thing, but as we're getting the calibration come in, we'll see it come closer and closer to the actual value. And there we go, we've now got a pass. And so we can see that, you know, there's very little difference between the two units. And so if we actually come back here and go have a look at, and you'll see that now we're fully calibrated. You know, so we've got our 10 meg there. And if I ran in the calibration on this one on the top again, it would come up to 10 meg as well. So that's how you calibrate. And we can see based on the signals that we got, we've got a pretty good agreement between these two units. Let me just take out this signal and drop in my GPSO, and you can see that very good agreement in terms of, you know, where things are. The peaks are not moving relative to each other, so you know we've locked in pretty well. I thought it might be interesting to just measure the phase noise of the two Victor-131 ovens, Jerry Sweeney's one and the original HP one. Now I'm going to use my 8563E, and I have the external clock turned on for it, so it's taking its 10 megahertz a signal from the GPSDO. You know, when you're doing a direct spectrum analyzer phase noise measurement, the assumption is that the phase noise of the device on a test is going to be much larger than the spectrum analyzer. I'm not entirely certain that's the case. In fact, I don't even know if that's the case here. So we're going to see one of, you know, three things. We're going to see two sets of phase noise graphs that are different, and that will show difference between the two ovens. We'll see two phase noise graphs that are the same, that will show that both ovens perform to roughly the same spectrum. We'll see two phase noise graphs that are roughly the same, that will basically show the noise floor of the spectrum analyzer. Now they won't be exact because there's going to be random movements, but if the lines are roughly in the same spot, then most likely what we're doing is we're measuring the phase noise of the test setup rather than the device under test. And that's, you know, totally to be expected because these are very stable and high, you know, stability, you know, ovens, time bases. So let's go take a look. We'll see what comes out of it. So we're going to go acquire this. We're going to acquire it from, oh, no, I just launched the plotter emulator. Hang on, phase noise. And we're going to acquire this from the 8560E. And the first one we're going to get is the HP oven. So let's run that. And, you know, the carrier is at 10 megahertz. So we're going to do that. And I can hear the unit working in the background. Okay, so that's for the HP. We saw the carrier at the 10 meg sources at 6.33. Let me swap the sources over and then we'll run it again. Okay. So I think, you know, well, I don't know. This is interesting because there is this little peak right about here, which is going to be between, you know, 100 and 200 hertz. So sort of like about 120 hertz. That could be causing a problem. Then again, I've just noticed that they have the cable running over the top of a power cord. Let me change that and see if that makes that 120 hertz line sort of go away. Okay, so I just moved that. I don't know whether that is actually conclusive enough or not. You know, we're seeing this little, if we can zoom in now, you know, if we look at, let me get rid of the HP one, you know, and you can see that we've got that little spike in there. So, you know, I don't know if it is related, but I think based, if we look at, like, you know, what we're actually, you know, most of what we're measuring there is probably the noise floor of the instrument, you know, because we're starting to see similar peaks here. This is the only one where we're seeing some difference. So I don't know if that's, you know, well, there's also some stuff here. But anyway, I think what we're seeing here, apart from that, is that these are very, very similar in terms of the quality of the, you know, in terms of the quality of the signal that they output. So overall, for the, you know, considering that the original HP one is virtually unobtainium, I'm very, very happy with the results that I've got out of that. So that's pretty much all I wanted to show, that we've gone in, we've done the upgrade. We've got 3 GHz support here now. We've got a high stability time base that's got a better value here. We can see that the sequences are locked together. So this unit is nice and done, 3 gigs, and all calibrated. The next step will be to go through and take a look at the performance testing for it, but I can do that off video. Anyway, I hope you found this interesting, and I'll catch you again later. Bye.